So I'm going to start with a description of phase-based ranging. And I think the fastest way to bore an audience and put them to sleep is to show equations. So sorry for showing the equations. So let's not focus on trying to understand the details of the equation, and let's look first at the bullet points or the main points of topic. So in phase-based ranging, it is a tone exchange between the initiator and the reflector. That means a tone gets transferred from the initiator to the reflector, and then the reflector transmits a tone back to the reflector. It's called phase-based ranging, but it could also be called round-trip phase, because the phase goes one direction and then the opposite direction. And if we look at the first bullet point, it says on channel K, a tone is sent by the initiator to the reflector and then received by the reflector. And the equation underneath it gives the phase that would be received by the reflector. And then there's kind of 2 points. There's a 2 pi fd component, which is a phase rotation that's caused by the propagation delay of the distance, and it's frequency dependent. And then there's a phi of I and a phi of r component. And the phi of I and phi of r represent the unsynchronized phase differences between the initiator and the reflector's PLL. Right? They're 2 devices, they're separate devices, they don't know each other. Right? There's no physical connection between them, there's a wireless connection. Their PLLs are not in the same state. They're at the same frequency, but not at the same state. So then, when the reflector receives that, they take that phase measurement, as shown in the first equation. And then both devices will keep their PLLs locked, and then they will switch transmit and receive modes. So the initiator, which transmitted initially, will then change to receive mode while keeping its PLL locked. And the reflector, which was initially receiving, will will transition to transmit mode while keeping its PLL locked. And then the reflector will then send a tone back, which is given by the second equation. And the important thing to note here is that 2 pi f d factor is still in the equation and is exactly the same as the first equation. But the position of the phi of I and phi of r have reversed. And that is saying by doing a two-way tone exchange, the error state or the ambiguity state, the differences between the initiator and the reflector's PLL cancel out. That error term disappears because they're equal and opposite in magnitude. So what that means is when you collect all the measurements, which is the third equation, the third bullet point, whichever device is doing the algorithm, the distance calculation, would aggregate all the measurements. You can compute the two-way phase rotation by the equation, the third equation. So basically, you get the two-way phase rotation. And then from this, you can estimate the distance if you repeat this process across multiple frequencies.